What happens to a steel hull at a depth where the ocean itself starts crushing machines built by engineers? Somewhere below 1,000 meters, in water so black it swallows every photon, a shape the size of a school bus is gliding downward without struggling. No thrashing, no panic. It is clicking softly, almost lazily, the way you might hum while looking for your keys. This is a sperm whale, and it dives here into pressure that would fold a submarine hull like a soda can. Not once, but dozens of times a day. And it does this on purpose. I know how that sounds. Footage like this always looks staged, or at least exaggerated for views, the kind of claim that gets stretched until it snaps. It isn't stretched. Researchers have tagged sperm whales making routine foraging dives past 600 meters, many exceeding 1,000. Some individuals recorded well beyond that on a regular basis, dive after dive, for most of their adult lives. Naval engineers spend fortunes reinforcing hulls to survive a fraction of that pressure, and even then, there are documented depths at which steel simply gives out. A sperm whale does this as a normal Tuesday, then surfaces, breathes for 10 minutes, and goes right back down to do it again before the day is over. So the obvious question isn't really the interesting one. How does it get down there without dying is the beginner's version of this mystery. The real question is why an air-breathing mammal treats a zone that destroys human engineering as a routine commute, and what that says about what dangerous actually means once you stop measuring it with a human body instead of a whale's. Start with where it's actually going, because this isn't blind wandering into the abyss. Somewhere around 200 meters, sunlight starts failing. By 600 it's gone entirely, and the water temperature has dropped hard enough that a human body would be shivering uncontrollably within minutes. Life down here doesn't stop, it just changes shape. This is the twilight and midnight zone, and it's dense with squid, some of them enormous, drifting in total darkness with nothing to hide behind visually because there's nothing to see by in the first place. Some of the animals living at these depths generate their own faint light, flashes and glows produced by their own bodies rather than borrowed from the sun, but that light is scattered, unpredictable, and useless for hunting anything moving quickly through open water. It's closer to a handful of distant matches struck randomly in a warehouse than anything resembling daylight. For a sperm whale, this isn't emptiness, it's a pantry the size of an ocean. The very blackness that reads to us as nothing is exactly what makes the hunting possible, because down here, sight has already stopped mattering, and something else entirely is doing the work of finding dinner. Think about what a human diver would face at even a modest fraction of this depth. Crushing pain in the ears and sinuses within the first few dozen meters, disorientation from nitrogen dissolving into the bloodstream under pressure, and a hard ceiling on how long a single held breath can possibly last, measured in a couple of minutes at best under extraordinary training. A sperm whale treats those same conditions the way a person treats walking down a familiar hallway in the dark. That contrast alone should make you suspicious that something structural, not just size, is doing the real work here. The first answer people usually reach for is simple. It's just a big, thick-bodied animal, insulated and tough enough to shrug off pressure. That's not wrong, but it's nowhere near enough, and here's the part that surprises most people. Water pressure isn't like a punch you can pad against with blubber. It pushes on every surface equally, from every direction at once, squeezing inward on anything rigid and hollow. Soft tissue barely notices it. So thickness alone doesn't explain why the whale's lungs don't rupture on the way down, why nitrogen doesn't bubble through its blood and joints the way it does in a human diver who surfaces too quickly, or why an object that would kill a person at a fraction of this depth is, for the whale, background noise. Follow the whale down and the environment itself keeps rewriting the rules of what its body has to deal with. At the surface, everything is familiar. Air, light, the rolling texture of waves. 100 meters down, the light has already thinned into a deep, directionless blue, and the pressure pressing on the whale's body has roughly doubled from what it felt at the surface. By 400 meters it's doubled again, then again, stacking relentlessly with every additional stretch of water overhead, water that has no memory of how far the surface is and simply keeps pushing. There is no wall to hit, no obvious limit, just more ocean layered on top of more ocean, and every additional meter adds real physical force against every square inch of the animal's body. Here's where the feature everyone notices first comes in: the ribcage. It isn't rigid the way ours is. It's built to flex and fold inward as pressure builds, and if you could slow the dive down frame by frame, you'd watch it happen in real time. As the whale descends, its chest visibly narrows, ribs sliding closer together, air pushed out of the delicate lung tissue and squeezed instead into rigid airway passages that don't absorb gas into the bloodstream the way lungs do. Picture a plastic bottle you can crush flat on purpose compared to one that shatters the moment you squeeze it wrong. The whale's chest is designed to be crushed on purpose, safely, every single dive, hundreds of times over a lifetime. But a collapsing ribcage only explains why the lungs survive. It says nothing about how the whale still has enough oxygen to hunt for the better part of an hour on a single breath, and it says nothing about why gas doesn't accumulate dangerously in its blood the way it would in us. That's a separate mechanism, and most of it is invisible from the outside. Inside, the whale's blood and muscle are loaded with extra oxygen-carrying machinery. More red blood cells packed into every litre of blood than we carry, and far more myoglobin saturating the muscle tissue itself, effectively turning the muscles into their own private oxygen tanks instead of pure oxygen consumers. As the dive begins, blood flow gets rerouted away from organs that can tolerate a temporary oxygen shortage, funneled instead toward the brain and heart, the two structures that genuinely cannot wait. This isn't brute toughness, it's rationing, precise and automatic, the same body running on a completely different budget the instant it goes under. And there's a second obvious feature people rarely think to question: that massive, block-shaped head. It isn't just for looks or bulk. Inside it sits an organ full of a waxy substance that the whale can warm or cool slightly by controlling blood flow, and the passage of air through its nasal complex, subtly changing its own density to fine-tune buoyancy on the way down and the way back up, so it isn't fighting gravity the entire dive, just nudging it. That same nasal structure is also how the whale produces the loudest sustained sounds of any animal on the planet, focusing clicks forward like a beam and reading the echoes that bounce back off squid it will never see with its eyes. The clicks themselves are generated by structures near the front of the nose, sometimes called phonic lips. Pairs of tissue that snap air back and forth through the passage the way a person might pop a knuckle, then send that sound backward through the waxy organ, which behaves almost like a lens for noise, focusing scattered vibration into a directed beam aimed out into the water ahead. Down here, in total darkness, hearing has quietly replaced vision as the primary sense during the actual hunting, and the whale is, in a very real sense, seeing with sound. Sperm whales don't do this hunting entirely alone either. Groups made up mostly of related females and their young travel together for years, and they communicate through patterned sequences of clicks that differ slightly between family groups, distinct enough that researchers can sometimes tell which cluster of whales they're listening to based on the pattern alone. Whether that qualifies as anything close to a dialect in the way humans would use the word is still debated among researchers, and claiming certainty there would outrun the evidence. What is documented is that these click patterns are consistent within a group and different between groups, which means whatever is happening acoustically, it isn't random. There's also a naming confusion worth clearing up here, because it changes the image in your head. A sperm whale is not a baleen whale, and it isn't hunting by filtering water for tiny drifting plankton the way a blue whale does. It has teeth, one row set along a narrow lower jaw, and it is actively pursuing individual prey animals in total darkness rather than passively sieving a cloud of them. That distinction matters for the whole mystery, because a filter feeder wouldn't need this kind of targeting precision at all. This is an active predator solving an active predator's problem, just doing it somewhere almost nothing else on the planet can follow. Watch a calf try any of this and the limits become obvious fast. Newborn sperm whales cannot make these dives. Their bodies haven't finished developing the oxygen storage capacity or the full ribcage flexibility yet, so for months they stay near the surface while adults take turns diving below them. Other members of the group circling back up to check in between hunts, sometimes described by researchers as a kind of babysitting arrangement among related females. This isn't the calf being deliberately taught in any sense the evidence firmly supports. It looks closer to a body that simply isn't ready yet, paired with a social group that doesn't leave young animals unattended at the surface. What looks like teaching might just be patience enforced by physiology, and the distinction matters because it tells you this ability isn't instinct switching on overnight. It's assembled slowly, tissue by tissue, dive by dive, across years of growth. Even once a young whale starts diving deeper, the early attempts look noticeably clumsier than an adult's. Dive tag data on juveniles shows shorter dive durations and shallower maximum depths than fully grown individuals, gradually extending as the animal matures, which lines up with a body still finishing its oxygen storage capacity rather than a skill still being taught. Mistakes at this stage are mostly about margin for error rather than outright danger. A young whale simply can't stay down as long or go as deep, so it surfaces earlier, misses more, and slowly closes that gap year by year until its physiology can support the same commute the adults make routinely. None of this evolved for spectacle. Every part of it, the folding ribcage, the oxygen rationing, the buoyancy tuning organ in the skull, the sound beam replacing eyesight, exists because something down there was worth the cost of building it. Somewhere in that darkness sits the actual pressure that shaped all of it. Food and the competition for it. Squid, including some of the largest invertebrates alive, live at depths shallow hunters simply cannot reach. Staying near the surface means competing with dolphins, sharks, and other whales for the same shallow prey. Going deep means walking into a place that punishes any real mistake, but also means arriving somewhere almost nothing else can follow. And the encounters down there aren't as one-sided as people imagine. Researchers examining sperm whale skin have documented sucker scars from squid large enough that no camera has ever captured the fight itself, only the aftermath written directly onto the whale's own body. That's an important distinction to hold on to. This is evidence of a confrontation, not footage of a duel. Whatever actually happens in that darkness happens without light, without an audience, in near silence except for the whale's own clicking, judging distance and shape purely from sound bouncing back out of the black. This isn't a chase you can picture the way you'd picture a wolf running down a deer across open snow. It's closer to two shapes finding each other blind, one of them using sound like a hand reaching out ahead of its own body. Distance changes everything about how that meeting goes. Far out, the whale's clicks travel loosely, spread wide, giving it a rough sense that something large is out there, without much detail. As it closes in, the clicking rate speeds up dramatically into a tight, rapid buzz researchers sometimes call a creak, the acoustic equivalent of a camera shifting from a wide establishing shot to a tight close-up, refining the target's exact position in the last seconds before contact. Miss that timing, misjudge the distance in total blackness, and the whale either wastes enormous energy on an empty strike or closes on prey capable of leaving those same scars behind. Down here, precision matters more than raw size, because raw size without accurate targeting just means a bigger animal missing in the dark. Here is where the story flips. For most of this, the instinct is to treat the depth itself as the dangerous part, the risk the whale survives in order to reach a reward. But depth isn't the danger zone here, it's closer to a sanctuary. Killer whales, the sperm whale's most serious natural predator, hunt visually in coordinated groups, almost always near the surface, where enough light exists to organize an attack and track a target moving through open water. Documented attacks tend to target calves or isolated individuals near the surface, and adult sperm whales have been observed responding by forming defensive circles, tails facing outward like spokes on a wheel, the most vulnerable animals protected at the center, using their powerful flukes as the only weapon pointed toward the threat. That formation only works because there's enough light near the surface for the group to see each other and coordinate the shape in the first place. Down in the black, that entire predator strategy stops working. There's nothing to see, nothing to coordinate visually around, and the whale that looks most exposed to us, alone in crushing pressure, kilometers from daylight, is actually the hardest version of itself to reach. The image people react to as terrifying is, from the whale's side, closer to a locked door. That reversal gets even stranger once you look at other deep divers solving a similar problem differently. Beaked whales push even further down and can hold their breath even longer, relying on their own particular balance of oxygen storage and a slower resting metabolism built for extended stillness rather than the active hunting a sperm whale does through most of its dive. Elephant seals reach serious depth through a different combination entirely. Enormous blood volume paired with thick insulating blubber, built more for cold tolerance than for active pursuit. None of these species are competing directly with each other. Each one carved out its own version of the same basic trick, descending into a place shaped like danger specifically to escape a danger that's actually worse near the surface. Size is where the comparison really separates the sperm whale from the rest of that group. A beaked whale weighs a few tons at most. An elephant seal, even a large male, tops out well under 2 tons. A sperm whale hauls a body that can weigh over 40 tons into that same crushing dark, and does it repeatedly, which raises its own quiet question. How does something that large manage the energy cost of a dive that size at all? Part of the answer is efficiency rather than brute force. The whale doesn't swim hard the entire way down. It angles its body and largely glides on momentum and controlled buoyancy shifts from that waxy organ in its head, saving active muscle effort for the final approach and the hunt itself, rather than burning it evenly across the whole descent. The sperm whale isn't the single deepest diver in the ocean. It's the one built to combine serious depth with serious size, chasing some of the largest prey available in a place almost nothing else can follow it into. Now bring humans into this, because we've already rewritten part of this world without most people realizing it, in more than one direction. Sperm whales rely on sound to navigate and hunt in a place with no light, but naval sonar and heavy shipping noise travel through that same water across enormous distances, sometimes disrupting the acoustic picture a whale is actively building in real time. Researchers have documented strandings correlated with certain sonar activity, though the precise mechanism linking sound exposure to stranding behavior remains genuinely debated rather than fully settled, and that uncertainty deserves to stay uncertain rather than get flattened into a tidy villain narrative. What is clear is that an animal built around silence and precise echoes is now hunting inside an ocean noisier than the one this whole system evolved for, and that mismatch, not the depth itself, may be the real modern threat facing it. There's a more immediate collision too, one that has nothing to do with sound. Sperm whales spend meaningful stretches of time resting at the surface between dives, sometimes floating nearly motionless while recovering oxygen debt built up from the hunt below, and that recovery window puts them directly in the path of large commercial vessels moving through the same shipping lanes. Vessel strikes are a documented cause of injury and death in several whale species, and a whale that just spent 40 minutes rationing oxygen in total darkness a kilometre down can find its most vulnerable moment isn't in the deep at all, but in the ordinary daylight it surfaces into to breathe. There is an older human collision here too, one that shaped the species' history directly. For more than a century, sperm whales were hunted specifically for the waxy substance inside that oversized head, once prized for oil lamps, lubricants and candles before industrial alternatives replaced it. A demand that pushed populations down sharply before international protections began recovering them. The very organ that lets the whale fine-tune its buoyancy and focus its hunting clicks in total darkness is the same organ that once made it a target on the surface, in daylight, for an entirely different set of reasons than anything happening 1,000 meters down. There is also a quieter, more careful echo of the whale's own trick showing up in human engineering. Submarine design has spent decades studying pressure tolerance, hull flexibility and buoyancy control. Some of that research directly informed by how deep-diving marine mammals manage internal pressure without structural failure, though this remains an area of ongoing study and inspiration, rather than one finished invention borrowed wholesale from a whale. It is less that engineers copied an animal, and more that the same physics forced biology and machinery towards similar answers from two completely different starting points. So go back to that opening image. A whale drifting downward into a zone that would crush a submarine, clicking calmly, apparently unbothered by any of it. It looked reckless. It is not. Every part of that descent is controlled, rehearsed across generations of bodies built specifically for this exact pressure, this exact darkness, this exact prey. The ribcage folds on schedule. The blood redistributes automatically. The buoyancy organ nudges density just enough to make the trip cheaper. The one predator that should worry it most simply cannot follow it down here. What looked like the single most dangerous moment of the whale's entire day is, according to its own physiology, closer to the safest place it ever goes. Right now, somewhere in that black water, another sperm whale is descending exactly the same way, clicking softly, heading toward the same crushing depth, completely unaware that any part of this should be considered impossible. It is not gritting through anything. Its ribs are folding on schedule. Its blood is already rerouted. Its clicks are already reaching out into the dark ahead of its own body. And somewhere below, something large enough to leave a scar is doing the exact same thing back. For that whale, this was never survival against the odds. It is just going home to eat, in the one place its most dangerous predator can never follow.